Chapter 6, Electrical Systems, Part 1 of 3. The questions that we're going to answer in this video: what are subatomic particles and how do they relate to electricity? How does the law of charges affect the flow of electricity? What are different sources of voltage? And what are the primary functions of conductors and resistors? The atom. The atom is the smallest indivisible unit of matter and the most basic building block of an element that still retains the properties of that element. At the center of the atom is a nucleus, which consists of tiny subatomic particles called protons and neutrons. A proton has a positive electrical charge, and a neutron has no charge. Orbiting around the nucleus are much smaller negatively charged subatomic particles called electrons. Electrons can be shared with other atoms to form chemical bonds. They can jump from one atom to another to generate electricity. Elements. Any material that is composed of only one type of atom is called an element. The periodic table of elements groups the known elements according to their properties and the number of subatomic particles they contain. Materials that are composed of two or more elements are called compounds. Ions. Normally, atoms have an equal number of electrons and protons. When an atom gives up or gains an electron from another, it becomes an ion. An anion is a negatively charged ion because it has more electrons in its shell than protons in its nucleus. An atom that gives up an electron to another atom has more protons in its nucleus than electrons. This is called a cation. Static electricity and the law of charges. The law of charges states that opposite charges attract and like charges repel. Current. Current is the movement of charge carriers, such as free electrons, holes, and ions. Electric current is the result of free electrons that are directed to move from one atom to another along a conductive path. Because electrons have a negative charge, they are repelled by areas of negative polarity and attracted by areas of positive polarity. Polarity. Polarity is a relative concept that in the electrical charges at one point in a circuit is identified as positive or negative in relation to another point within the same circuit. The terminals of a 9-volt battery are labeled with plus and minus signs. The terminal with the minus sign is called the negative terminal and is more negatively charged than the positive terminal. Electron orbits. Materials that allow electrons to flow easily through them are called conductors. Electrons from orbits, called shells, around an atom's nucleus. Each electron shell can contain a set number of electrons. The maximum number of electrons that any one shell can hold may be calculated using the formula 2n squared. The valence shell. Materials that are excellent conductors have only one or two electrons that occupy the outermost electron shell, called the valence shell. The atoms of such materials can easily give up these electrons to neighboring atoms. Sources of voltage. If an electron current is the result of free electrons that are directed to move from one atom to another along a conductive path, what directs electrons to move in the first place? The answer is voltage. Several different sources of voltage are used in electrical circuits, including batteries, generators, photovoltaic cells, thermocouples, and piezoelectric devices. Batteries. A battery generates a voltage by converting chemical energy into electrical energy. This involves a chemical reaction between two different electrodes that are separated by a chemical solution called an electrolyte. The chemical reaction frees more electrons in one electrode than in the other, making one of the electrodes more negatively charged than the other. Generators. A generator is a mechanical device that converts mechanical energy into electrical energy. A magnetic rod is passed through a coil of wire. When the rod is moved, a current is produced in the wire that is measured by a galvanometer, which detects the presence of electrical current. Repeatedly moving the magnet back and forth will result in an alternating current. Photovoltaic cells. Semiconductor materials such as silicon and germanium are used in the creation of PV cells, which generate voltages as they absorb the energy contained in the photons of light. When connected to a circuit's conductive path, to power an electrical device. Thermocouples. A thermocouple is a device that consists of two dissimilar metals that are bonded together. Thermocouples are often used as temperature sensors in electronic temperature control systems. Piezoelectric devices. Some materials will generate voltage when subjected to mechanical pressure. Quartz crystal is one such material. This phenomenon is known as the piezoelectric effect. The amount of voltage produced is directly proportional to the applied pressure. Friction. Static electricity results from the physical separation and transportation of charges due to friction between two objects. Some common electrical units. The current, shown by the symbol I, is the rate of electrical flow. It's measured in amperes, and the symbol is the capital letter A. Voltage is the letter V. It's the definition of electrical pressure. It's measured in volts. Capital letter V is the symbol. Resistance, or R, is the opposition to electrical flow. It's measured in ohms, and the symbol is the capital Greek letter omega. It looks like that. Conductance, shown as G, is the ease of electrical flow, measured in Siemens. The abbreviation is the capital letter S. Power is P. It's the rate of doing work. The unit of measurement is the watt, and the abbreviation or symbol is W. The charge is Q, the surplus or shortage of electrons. It's measured in coulombs, and the symbol is capital C. Current. If you were to place a negative charge at one end of a conductor and a positive charge at the other, electrons would flow from the negative side to the positive side. The flow will continue until both sides of the conductor have equal charge. The intensity of quantity of electrical current, I, is the number of electrons flowing past a given point in 1 second. Current is measured in amperes. 1 ampere is equal to 1 coulomb per second. 1 coulomb, which is the basic unit for electrical charge, is approximately 6.24 times 10 to the 18th electrons. Current that flows in only one direction is called direct current. Current that changes direction is called alternating current. Voltage. Electrons are directed to move from one atom to another as a result of electrical pressure called voltage. Voltage, shown by the letter V, is the difference in charge between 2 points. The greater difference in charge, the greater the voltage will be. The unit of measurement for voltage is the volt. 1 volt is the difference required to move 1 amp of current across a conductor that provides 1 ohm of resistance. Resistance. Electricity experiences resistance as it flows. Electrical resistance, or R, is the opposition to flow of electricity, which is measured in ohms. Materials such as copper and aluminum are good conductors and offer little resistance to the flow of electricity. Polymers, ceramics, and woods act as insulators in that they provide a great deal of resistance to flow of electricity. Conductance. Conductance measures how easily electricity can pass through a material. The unit of conductance is Siemens, and conductance equals 1 over the resistance. Power. Power is the rate of which electrical energy is transferred or transformed. The metric unit for power is the watt. In a direct current circuit, power is the product of voltage and current. Power equals voltage times current. Charge. The basic unit of electrical charge, Q, is the coulomb. 1 coulomb, C, is equal to 6.24 times 10 to the 18th electrons. This ends part 1.